In the meantime, you know that like every time you watch Star Trek, it's like you wonder that how their international intercommunicators work. That every time there's a Klingon and Enterprise calling each other, it always seems to work and no dropouts and everything. So I guess we're still ways to go to that kind of world. Uh, all right. Hey, first I want to start with like complimenting that. Thank you for the excellent presentations. Really interesting, really deep dive. I really like that kind of stuff, and I'm sure that everyone else here is appreciative of that as well. But I'm actually here to talk a little bit, a kind of a lighter subject, so to speak. And from my part, let's keep this interactive. So if you have any questions at any point, just raise your hand and we'll throw you at with that cube. And you can ask a question. And I'll start what my colleagues usually say that is my favorite subject. So talking a little bit about myself. So my name is Rolf and I work for Cybercom. I'm a CTO of Cybercom AWS Business Group. And we are just recently added AWS Premier Consulting Partner among very few in the Nordics. And what I do is I'm guy with the sticker. I know that Gunnar is recently become also a guy with the sticker as well. There's this funny story. Well, I don't know if it's funny, but I get to meet Jeff Barr at last reInvent. So my colleagues thought that I was a little bit smug about that. So they created me my own sticker and handed it to me. And I was like, okay, I need to decide if I'm going to be embarrassed or own it. I decided that I'll own it. So nowadays I'm the guy with the sticker. If you ask AWS solution architects, they'll probably know me by this description. I'm community leader here in Stockholm as well, and running also the Helsinki area meetup, which is, I guess, the biggest one currently in the Nordics, 1,800 members and counting, and also AWS Partner Ambassador, one of two in the whole of Nordics and Baltics. All right, that's about me. I'm not going to talk any more about me today. Uh, Today, we are going to be talking a little bit about AWS DeepRacer, what's that about, and a few weeks back there was AWS Summit in Stockholm. A quick show of hands, how many of you were in the summit? Yeah, oh, okay, a lot of you. So there was like, this was also mentioned in Ian Massingham's keynote as well, that we were actually at that point of the day already leading the competition, but I think you couldn't have missed that this was going on. So yeah, that's the outline that we're going to be covering today. So I'm not Jouni Luoma, but Jouni Luoma is my colleague from Cybercom Finland. Yes, I'm actually a Finnish guy as well. So Jouni is an interesting guy because he used to work in our HR. He used to work as a customer service manager for years, and then he decided that he wants to learn something new. So he enrolled in University of Turku to learn machine learning, and he went there for 1 year and came back for us like a summer intern. But he had like some serious talent that he had learned there. So he managed to drive the track at the summit track for 8.7 seconds, and that's like a seriously fast time. And the fastest ones in the world are just shy under 8 seconds. And yeah, we decided like a few weeks before, we decided that this is something that we want to making happen. It was like me and Jouni and a couple of other guys that decided that let's set this up and see where it leads us. So, what is AWS DeepRacer? It's a car, toy car, basically. And when it was announced in reInvent last year, people were like, "That what the f is this? What's going on?" And it's autonomously driving based on reinforcement learning. And the thing here is that probably AWS is not in the business of making toy cars. But rather what's happening here is that they're actually trying to democratize technology. So they build something that brings technology closer to people and something that is easier for people to understand that what is deep learning, what is reinforcement learning, how does it work, have like dashboards and tools that are really easy to use to get like decent results. So that's kind of the end game, and also partially naturally promote their services, that how they provide kind of this higher abstraction level services around really complex technology at the bottom. Um, at reInvent, it was announced that it's going to be a global racing league. So at each of the summits going around the world, there's a competition, and each winner gets full paid ticket to go to Las Vegas next early December. So a little bit basics. So how DeepRacer works, that when it's running around the track, it has camera, and then there's a micro-sized computer on board, and it analyzes the images from the camera, and then it makes decisions and trains the model continuously. So inference means basically like locally augmenting the learned model all the time. It's been fully like productized, so there's like a console for training and developing the model, and underneath it runs RoboMaker and SageMaker. So it's based on those like best of the breed built tools provided by AWS that you can actually use for any other purpose as well, not just like training a toy car. There's also a virtual league, so you can train a model and run it in a simulator and see in a simulator world how fast does your model go around the track. We actually found out that running with the exact same models in the real world track is actually a bit faster than in a simulated world, but you get a kind of a idea that how you position against other teams and other people doing this globally. So it has some relatively serious computational power inside, considering that what size of car this is. If you recall AWS Deep Lens, it's actually the same camera which is inside. And funny thing is that this is not the front of the car, the gray part. The front of the car is actually the black part. That is where the camera is. And yeah, it's built on some miniature car, micro RC car platform, but it's like seriously good quality. And we actually managed to grab a couple of these from last reInvent. There have been like incredibly short supply. Now during the autumn, probably they are becoming more and more available. Yeah, there's the car without the shell. So there's like the DeepRacer camera, and then that's like a basically lithium-ion USB battery pack there on top, and some serious coil springs and rubber tires. This is how the simulator looks like. So it provides you with images of simulated track, and then you just run your algorithm against that track. In the physical world, all the tracks, as far as I know, are exact similar. In the training simulator or in the virtual simulator, there are like actually several tracks that you can choose from. Yeah, so this was pretty much covered already. So if this is interesting, just go and try it out in the virtual world and see how you compare against global competition. Then a few words about reinforcement learning and why it's a different or specific thing inside like machine learning as a concept. So reinforcement learning is one type of machine learning, and alongside supervised and unsupervised learning. And how reinforcement learning works is that the agent, or basically the model running somewhere, is trained by giving it constraints, and the model, by trial and error, trying to enhance its optimization. So basically, in layman's terms, you will either reward or punish the model from the actions that you find that it shouldn't do, or for the actions that you think that it should do. So this is kind of a bit of a different approach than on the kind of a machine learning where you tell the actual outcome that you would want the model to strive for. I've used sometimes an example that in the track, if you would give the car the task that once you cross the finish line, or start moving on the track and cross the finish line, try to find the optimal way to again cross the finish line without going from the track. So if you don't set any boundaries to the model, it could decide to back up again across the finish line, because that's what you told it to do. So the reinforcement learning doesn't work in a way that you will expect of it having some outcome. So you will guide it by giving it boundaries, that these are like the boundaries where you should be operating. And then you will see what the machine thinks that is the optimal way. Okay, so this is like a short description of like agent doing some action, investigating the situation, either getting feedback as a reward or punishment. And this model is working as like partially observed model. So what that means is that the car or the model doesn't know fully the observed world. So it can't know that what's happening behind the next corner. It will always only know that what it sees at the moment, and then it will decide on the action, and based on the action the model either punishes it or rewards it, and that's like how it learns. All right, then what actually happened? So your job is basically selecting the model that you want to use, giving it some base logic, and then the DeepRacer stack basically takes care of the rest. So it's convoluted neural networking under the hood, but you don't really get to see it that much. So it's kind of also it kind of levels the playing field a little bit, because this is not supposed to be kind of competition between like doctors in machine learning. So you are not like building the neural network, you are like building the model which is run on top of the neural network. This is how it looks like. So you, for example, give it certain constraints to the model, that this is kind of the maximum steer that you want to allow, and these are like the maximum and minimum speeds that you would want to use. And on the rightmost picture, the top left, there is actually the kind of the more or less the competition circuit, or how it looks like. And similarly, as if you ever watched like IndyCar races where they run on oval tracks, on here as well, the cars always suffer from the only right-hand turn that is on the track. So that's when you have like uneven split between left-hand turns and right-hand turns, the car usually learns pretty much more how to turn left rather than to turn right. Okay, so this is pretty small, but building a rewarding logic, here are basically kind of the inputs that you can use for the car, that how does it modify its behavior while it's driving. I will share these slides with you, so don't worry, you can like check this also later, that what was there. And then you will also, there's like an example of a reward function, and the hyperparameters are like specific thing for machine learning. So hyperparameters are basically parameters that you give from the outside that are specific for the used logic or the used function inside the machine learning model. So that's those are different if the model uses a different type of algorithm inside. Those sometimes those are not like matchable to any kind of real world things, but rather, as said, are specific to the model. All right, so then the first model was doing 45 seconds a lap in the simulator. And compared to that, in the world, the fastest track times were around like 8 seconds at that point, so not feeling too confident at this point yet. And continue training, more rewards for getting more speed, like rewarding the behavior that we wanted the model to have. Continue training, continue 12 seconds, still percentage-wise pretty far away from the 8 seconds. So then what happened? We ordered full-size track. That's track consists of like 4 huge rolls printed on kind of this PVC plastic material. Basically, it's the same material that you like these advertisement roll-ups are made of. It was big. It's like 8 by 6 meters. So at our Tampere office, we needed to like clear basically our like kitchen and resting area to have this, and not too all of my colleagues were too fond of us like removing all the furniture. So good enough. Let's try what happens. When you're driving the vehicle, there's a dashboard, and basically the only parameter that while you're competing or while you're driving on the track is that what's the maximum speed that you want to allow the car to drive. Everything else is handled by the model. That's like only interaction that you can have. All right, if the audio probably doesn't work, but let's now we should see a video in there in the little shabby, but so a lot of that happened, and we had this car actually at the summit at our booth, and all the plastics were like bumped in and twisted, and this car goes seriously fast, and when you bump it to the concrete wall, it gets a little bit bent. And then on the next one, this is one of the more like successful runs. That was probably like lap time around like 10 seconds or so, so we were getting close. The things were that the visual world outside had a lot of impact, so the lighting conditions impacted a lot that how fast the car could drive. And there was actually a funny thing that what happened on the actual summit circuit. So Joni was driving the car, and then there's like the AWS employee. If the car gets out of the track, that the kind of official then takes the car and put it back on the track. So there were like lights coming from above. So every time that the operator was like between the car and the light, there were shadows on the track. So Joni was at one point shouting to the official that, "What are you doing here? That go sit in the corner. That I want to like now drive a fast lap." So it was like really. For the fastest laps, you really needed to take a lot of risk, and then high risk, high reward type of approach. As said, I even tried to attach polarizing filter to the camera, so we tried everything. Also, the track was quite, as in Finland we say in the race circuits, the track was very slippery. So that was one problem as well. So even in the end, if we had the kind of full-size track, it was reflective, it was more slippery than the real track. But I don't know, maybe it paid off in the end because we had to rehearse in the more severe conditions than what the actual competition track was. Then the race. The doors opened 7:45 and Jouni was the first one on track at 8 sharp. It was split to 4-minute turns in the track, and they were providing all the cars, so it wasn't our car that we were using. You just took like your model on a USB stick there and gave it to the officials, and then you were running with the truck and the cars that they provided. 11 seconds on the first try. Then sometime around like 11 a.m., 12 a.m. or something like that, he only hit the 8.7 like the record lap, and after that he couldn't like improve anymore. All the top 5 contenders were continuously going to the track, so it was like really intense. Everyone wanted to win. So here's an example. Let's see how shabby the video now is. But this is like the, and it at points it goes really close to the borders, but the rules were that as long as even one feet is on the track, so to speak, it's counted as a valid lap. So that I don't know if this was like the fastest lap, but definitely one of the fastest. Okay, and then like this was like taken from like last seconds when the last contender was on the track. And then there you could see that the last contender actually smashed the wall, and then you only knew that, okay, now he had won. All right. That was our story. So please, any questions that you would like to know? Yes, there. So the question was that how much training time we did put into the model. So as I said, we started like 2 weeks before, and Jouni was actually working through the weekend and all through the nights because that's when the office space was like quiet and the conditions were like flat. So can't really say for sure, but definitely like dozens of hours in total went to like but I don't know that how many iteration actually was the actual model that he used in the like the final run, because even at the competition it was like the model was changed between runs, like trying out what works and how much maximum speed can you give the model and so on. So I don't actually know that what was the exact, but it was the models that were the fastest were really unstable. So it was really like going 5 times and 4 laps were really bad and 1 was really good. So that was basically how that was achieved in the end. Yes.
So what's your next plans after this? Are you gonna bring this beauty to reInvent this year and gonna compete out of everybody?
Let's see. There's some seriously fast lap times have become emerging. Like when the circuit or the summit started, it was like the fastest were like 10, 11, 12 seconds, and when Jouni had this 8.7, there was like only one time under 8 seconds, and Jouni was probably the 3rd or 4th fastest in the world at that point. And the competition is getting, for example, I just saw like Ryan Cronenberg. I guess you probably almost everyone knows the guy running AWS Cloud or a Cloud Guru site. He became 2nd in one of the summits, and at least the 2 winning times were both under 8 seconds. So naturally, Jouni is going to be concentrating on making this even better and like being a serious contender in the finals in the reInvent this year. But you never know, the going gets tougher.
Cool work.
Yeah, thank you. Great. If there are any more questions, I will invite Gunnar back to the stage.
Hey.
Yeah, I hope you enjoyed it. This was like lighter snack in between.
Hello. Can you hear me? Yeah, there we go. Thank you very much, Rolf. How do we get back to the